Okay, I'm hoping I figured this out. So we're gonna do a video of this. All right, so problem of the day, what is point A? To the left 3, all right? To the left 3, up 3, so negative 3 comma 3. B, all right, so we always do the X first, so X movement is nowhere, so it can be 0 movement, 0 comma up 2. C is to the right 5, up 2. To the left 3, up 1. To the right 3, down 2. To the left 9, down or up nothing. Or just go up, no up or down. All right, we're going to focus on midpoint. So basically, if you're given two endpoints on a coordinate plane, we're going to try to figure out how to find a midpoint and also maybe find an endpoint using the midpoint formula. So what does that look like? So students will develop and apply the formula for midpoint. So, all right, so let's review a couple vocabulary. Coordinate plane. It's a plane that is divided into 4 regions, right? So we're going to be plotting points on these planes. I'm just going to remind you, quadrant 1 on both coordinates are positive, and then all that stuff there tells you what that is. All right, so again, if I'm talking about a right triangle, all right, the two orange sides here form the right angle there. Those are called legs, and then the black side there is called the hypotenuse. All right. All right, so midpoint formula looks like this. To find the midpoint between 2 points that are on that coordinate plane, you're going to basically, you see that x1 plus x2, and then divide all that by 2, comma, y1 plus y2, all that divided by 2. And those little subscripts just means, look, I've got 2 points on there. So what does that look like? All right, so what's that look like? So here's my graph with a segment. I want to know the midpoint of that segment. I'm trying to find out where does it cut it in half? Where does it cut it in exactly in half? So what I do is I label the points. All right, I call one of them x1 subscript y subscript 1. Right, the other one's going to be x2 subscript y subscript 2. All right, so it doesn't really matter which one you call it because it's going to end up working out the same. So it means I'm going to have -6 plus -1, and ignore this minus thing. I don't know what's going on with that. And then 2 plus 1 over 2. And then you just do the math. 7 over -7 over 2, and then 3 over 2. And again, they're just supposed to say plus. I don't know what that minus, little accidental marking there. And then -3.5, comma 1.5. All right. And then just to show it to you, you plot the point. If you use the grid, and when you're doing these problems, put them on the grid, put the 2 endpoints down, and then get you an idea, at least, about where it is. So that way, if you get some weird answer like that comes out over to the side, not anywhere on that segment, then we know, what did I do wrong? I must have punched in something wrong or put in a negative, or maybe I didn't put in a negative sign or whatever. All right, so here's your point. All right. Find the midpoint between these 2 points, 2 comma -9 and 4 comma 9. So I'm not going to look at the graph here just to show you can be done. Call one of them x1, y1, the other one x2, y2, right? And then just plug the numbers in. So x1 and x2 are 2 and 4, so 2 plus 4, divide by 2. And then y coordinates are -9 plus +9. So you work those out. You get 6 comma 2, and you're going to get 3 comma 0. And then let's just check it on a grid. All right, so I'm going to plot the 2 points that were given. And then the midpoint should be 3, 0. And if you look to the right, 1, 2, 3, 0, right there. So looks like we did it right. So we'll say that one's correct. All right. Great way to check your work is to actually plot. All right. So again, this time now we're given the endpoint and a midpoint, and it's asking how do you find, or this is how to find an endpoint if you're given the midpoint and the midpoint and one endpoint. So we're actually trying to find the other endpoint. That's the question here. That's the problem. So let's put down the endpoint that's given, C, and the midpoint. So that means if I'm using my brain, I draw that line down below somewhere where that says x2, y2 is my other point. And we call this other endpoint x1, y1, right? Called x1, y1. So I'm just trying to solve for that. So in other words, 1 plus this number, 1, So put those numbers in. So 1 plus the x plus 2, 1 plus the x2 down there, divide that by 2 is going to give me what? It's going to give me this 3. So I set that equal like that. And the same thing here, this 4 added to the y2, then divide that all by 2. That gives me this equation over here. You can see me circling that around. And we know it's going to all equal to -1, right? So I just set it equal. Now I'm just going to solve. So you could either use this as a proportion and divide, set it over 1 and then just do the cross products, or you could actually multiply by the inverse operation times 2 to both sides on both, and you're going to get this equation on this side. And so you're going to then subtract 1, and then you're going to get the value of the x subscript 2 is equal to 5. And then over here you can multiply both sides by 2, or you can use cross products. There's 2 ways you can do it. Either way, you should get that new equation. Then you subtract 4, get the y2 by itself, and you get 6. So now I know my 2 coordinates. Now I know my x2, y2. I've solved the problem. All right. So let me get my, there it goes. All right. So there it goes. 5, -6 is my happy result there. And that kind of makes sense when I think of where that line's at. That looks the midpoint, 5 to the right, 5 down at 6. That means that hits it good. If I were to come up with some other answer that doesn't fit somewhere down in here, I said, what did I do wrong in my work? So a lot of times if you graph, you can sometimes fudge around and kind of tell where the answer is. And these help on multiple choice ACT questions too, if they ever give you a grid. You can kind of, sometimes multiple choice, you can kind of figure out what your answer is and eliminate choices on multiple choice tests. Just a little side thing there. All right, so to find the distance between 2 points, there's actually 2 ways you can do it on a coordinate plane. One way is use the Pythagorean theorem. That's where we know the right triangle. So you have 2 points. What does that look like? You have the -2, 1. You have my segment. All right, what you think of that segment, and what you do is you drop a measurement down and a measurement over and measure those. So it's dropped down what? Let me get the point there. Sorry. So A is in B, and then A is 5, and B is moved over 7. So you actually have, because you can count along those lines, those straight down, you can measure that as 5. You can measure this across as 7. But the blue part is the distance we're kind of finding, because it's diagonal, we can't really just measure it straight out. So we know it's probably going to be somewhat more than 7 because it's the longest side. So hypotenuse is always longest side. So now what I'm going to do is just substitute. So I want to call A, B, and C here. All right. Right triangle, A, B are my legs, C is my hypotenuse. And that's what these A and B represents, the legs. All right. So now I'm just going to plug in the numbers. A is 5, B is 7, and C is just C. So it's A squared plus B squared equals C squared. So 5 squared plus 7 squared equals C squared. Let's just do the math. So that's going to give me 74 is equal to C squared. And then C squared just means a number times itself is equal to 74. Well, if I just take the square root, that's what a number times itself means. So the square root of 74 is about 8.6 across. All right, and then I'm going to also do the distance formula. So that's that for that, and then a happy face. Now, another way you can do that same problem is using the distance formula. So it's plot the points, segment. We're not going to draw a right triangle, but what is the difference when I drop that red line that used to be there? Well, it's still the difference in the y coordinates, right? 6 minus 1 is that 5. And then this x2 minus y2 is this distance going across when we had the right triangle is the difference in the x coordinates. So basically we're doing the exact same thing here. So this distance formula is the same thing as comes right from Pythagorean theorem. All right, so I'm going to label one x1, y1 subscript, and then x2, y2 subscript. All right, and it really doesn't matter as long as you stick with it. And I'm going to just call this x, and then I'm going to go with those numbers. All right, so now I'm going to use the distance formula. I'm going to plug in the numbers. So what is x2? x2 is 6. I'm sorry, x2 is 5, excuse me. x2 is 5. That's why I label them, because you can get your eyes mixed up. I just did it. Case in point, just do it to teach your ass, because I know the tendencies, and so a lot of times, oh, why do I have to do that? It's extra work. Because of what I just did, all right? 5, then minus -2. So we're just going to plug in -2 for the x. All right. Then we're going to do 6 for the y, 2 minus 1. So, all right, plug those in. It's going to be squared. Now we just figure out the parentheses inside, which gives me 7, and then 5. And then you get 49 plus 25. And then that's going to give me the square root of 74, which is 8.6. So same problem. And again, the reason why it comes out the same is because it comes from the Pythagorean theorem. Because if I were to drop the distance down, that is the distance. 6 minus 1, that is 5. That is that drop down length of 5. And if I do subtract the two x coordinates, like it says I do in this distance formula, that's just the 5 minus the -2. That gives you that 7 length across, just like in the previous slide. So pretty straightforward here. So I believe we are complete with finding the midpoint and the distance. I think I told you just doing the midpoint, but I actually went to the distance formula. So we'll just go with that. Lesson quiz.